Welcome to Onshape Simultaneous Sheet Metal Unfolded. My name is Mike LaFleche. Some people call me the Professor. I am a longtime CAD and PDM person. I've been around the block, been a SolidWorks person for about 15 years before joining Onshape about 10 years ago. I also worked in the real world as a design engineer. One of my first projects back in the mid-90s was a cement mixer for the British Ministry of Defense. It was a ton of sheet metal, and I just really have loved and fallen in love with sheet metal ever since then. You know, big cement hopper, sheet metal, welded stuff. It's how can you not like that, right? So that got me into this stuff, and I haven't looked back since. I just love CAD and manufacturing and sheet metal and all sorts of manufacturing processes. But sheet metal is a great way of expressing your designs because it's cost. The cost of it is fairly low compared to other manufacturing methods, as well as it's fast, right? You can find a local sheet metal vendor. You can throw a rock and you can probably find a sheet metal vendor, and you got to develop relationships and work with them. But it's like this is a great world that we live in, that we can just get parts stamped out and made to suit our needs. So today's session is going to be exciting because it's going to be highly interactive. I see everybody found the comments already. Welcome. Definitely don't be shy. I might ripple up comments that make sense to show for the entire community. And if there's something that isn't something that we want to present live, I'd be happy to follow up with you later. But we have 45 minutes to an hour here together, depending on how things shake out, and we're going to have a lot of fun. So let's get right into it. So let me swap my screen here so you can see, what I'm going to be talking about here. And one of the questions that came up just now from our new friend Eddie, who is a new Onshape user here, he asked if we'd like to share designs with a sheet metal engineer, right? So these are some things that we'll answer today, and it's all related. Onshape sheet metal is very special, and we rethought how to accomplish sheet metal geometries based on how people interact with sheet metal manufacturing and OEM manufacturers, right? And if you've seen anything about Onshape, if this is your first time looking at something like Onshape, I will explain it a little bit. But if you're an Onshape user, customer, longtime customer, you're going to get some good stuff out of this too. But you've probably heard this, right? This is a trend in engineering and manufacturing, is to design hardware like software, because the software industry has done a pretty decent job at keeping control over code and software and working in parallel paths, because software projects are very large. You think of a large application, or even like, everybody's played a video game, like a fancy, PlayStation video game or something. It's probably thousands of engineers writing code to go into those things. So they had to develop really good processes for managing parallel workflows. And traditionally in the CAD world, it's been very difficult to do like really good parallel workflows because of the way file systems are made. So, we see people going from this traditional waterfall, passing the buck or a baton from one user to another to get work done, because only one person at a time can open a file in the world of / kind of file management, right? If you've been around like me, you remember, / and where, file servers and things like that. But in this world, it's becoming kind of strange to deal in that world. And most people are used to, sharing online, sharing like Google Docs and things like that. The agile design approach is something that I might bring up once or twice during this session, because it will enable more parallel workflows, eliminating like these work silos, right? So one of the things that we talk about in agile design is failing fast and finding problems sooner. So like, I'm a big advocate of like working very closely with your supply chain. And if you take a look at, how product development happens, your level of influence as soon as you put pen to paper or mouse to CAD is very high, right? That's when you as an engineer have the most influence over the design, right? But the moment it leaves your screen and is shared to somebody else, that's when the level of influence starts to wane, right? And if you find an issue, there's this metric called cost of change, and the cost of change later in the product development process, as you go from concept to prototype to pre-production to sales, gets higher and higher, right? So you want to avoid making changes past that inflection point right here. But that inflection point is pretty far down the design cycle, right? You know, you're finding those changes, you're making these changes in this middle section. But what if you could front load your design effort so that you'd fail fast, find problems sooner, right? And this is not a new concept. This is from, the concept of modified agile for hardware design is a new concept, but this like thought process of this thought train of finding problems sooner is not brand new. It's, this is from Boyd Paulson back in December 1976, designing to reduce construction costs, and you can find that online. So how do Onshape customers produce sheet metal, right? So, and I'll do a little quick explainer about Onshape here as I get started, and we'll get into the dirty details here. I'm just going to pick there's many workflows to design products, right? I'm just picking on one for the straw man for our presentation here. But, there are many workflows where you could go from flat pattern to folded shape to flat pattern, to get these things manufactured. But let's just pretend that I'm an OEM manufacturer producing a product. In this case, we're going to be working on this like shape here, this mobile generator chassis, which is made of many, many pieces of sheet metal kind of fastened together, whether they're welded or fastened with the bolts or PEM nuts or whatever it is. So as the OEM product designer making that shape for that chassis, I know a certain amount, but I don't know everything. I need to communicate with my sheet metal supplier because they have equipment. Like they're going to be using certain gauge sheet metal. They're going to be using certain types of tooling and bend and air presses, things like that I might not be familiar with. And they might need to help me adjust my design to suit quick and accurate and cost-effective manufacturing, right? So you can imagine finding that out sooner is going to be a big help. I can tell you a million stories, some personal, from my design day experience back in the mid 90s, when I was doing that cement mixer that I was talking about. So that internal and external communication, we'll talk about that. And Onshape, the manufacturer will then manufacture it and then send it back for you to qualify, through an inspection process, right? So what we're going to try to do is on this chart, take that arrow and move it up, right? And all that movement is savings, right? So if we use Onshape, there's other software that are part of our product family for supply chain interaction called Arena PLM. We're not going to talk about that too much today, but that's also a partner that we have to do, supply chain and quality and inspection as well. So let's start with Onshape and CAD, right? You're here to see a CAD demo, I'm sure, and I'm going to give you one. Know that Onshape is a full-featured CAD system that's feature-based parametric modeling that's similar to what you would see in Creo from PTC or SolidWorks or Inventor from Autodesk. It's a program designed with that way of thinking of that parametric design where you put together parts assemblies and you make drawings of those parts and assemblies. Onshape can create configurable data for variant design. We have libraries, and we work with this multi-part modeling, which really works well with sheet metal, frames, and weldments, and I'm going to go right into it right now. So let me stop sharing that screen, and I will present another screen here for you. Okay. So here is my Onshape window here, and maybe I'll just go full window here so you don't see me talking just for a second so you can see the full experience. I've signed into Onshape here as a a user as like the manager right here. So when you sign in Onshape, you sign in as a user. Essentially, it looks like this when you sign in. You sign in with your email address and password. Nothing to install. Full SaaS. There's no CAD file that ever goes to your computer. You can always export data. You can release data, securely share your data, but there's nothing to install and there are no CAD files that you're managing on your computer. And that enables this finding problems sooner workflow, as you'll see. And, when you work in Onshape, you create these things called documents. This is a document right here. This is not the focus of this particular webinar. I'm going to create that mobile generator shape as you saw before, but this is an Onshape assembly made of released parts. Here is an Onshape part studio, which is the definition of the parts, right? How I'm making it, sheet metal parts, the flat patterns. You're going to see today in Onshape, this is why we call it simultaneous sheet metal. And I'm going to explain our thought process as to why we did it this way. But this hinge, for example, is made of several parts, 8 parts, as you can see right here in this one feature tree with 63 parts. So think about that. If you've come from another CAD system like SolidWorks or something like that, we have a feature tree, and all those features are creating 8 parts. I didn't have to save those out as separate files and manage and juggle /file references. Here are the flat patterns for each of the components, as well as a bend table showing you the bend calculation and the bend radius as well. So this is simultaneous because you're seeing 3 views of the Onshape data, the flat, folded, and bend table state in 3D. As you make changes, it changes in all the places. And of course, you'd be able to export that for manufacturing as a DXF with the naming that you're looking for. And I'll talk about this as we go forward. So this is just a little preview. All right. So let's get into how we would construct this mobile generator right here. And I'm going to pop this open right now from scratch. It's a full product. I'm going to open it at a certain configurable size, right? This is an Onshape assembly with configuration data. And, this is something I just kind of measured up, one of these mobile generators that you'd see at a construction site or something like that. There's a nice chassis frame here, but of course I saw a whole bunch of sheet metal on this and I thought it would be a great example to show how the Onshape sheet metal works. So let me just go back to full screen here. I'll just go full screen so we get the biggest window possible. So when we look at this design, there's a lot of parts that interact with one another here in Onshape, right? In the CAD model. So wouldn't it be nice if we could design these parts together in a way that's performant and works for downstream operations, okay? So if we go to our, what we call a part studio, you can see this cabinet. I have 54 features and 23 parts. This is probably the upper limit of what I would do in like a single part studio for constructing a whole bunch of parts. And it's because these are the parts that are related. I'm designing them together because they're just like, peanut butter and jelly. They need to go together. They need to be designed together, work together. There's going to be some holes, like some counter bored holes in here that go through here. All right. So let's try building something like this. And I'm not going to like do the whole thing here in one session here, but I want to give you my thought process on how to build something like this and how I would go about doing this. And the first thing I would do is to create a layout like this. And I'm going to start in a brand new document. I'll just go to my, I'll get out a full screen here. I'm just in Chrome here in my browser, and I'm going to hit the Onshape logo holding the Command key because I'm on a Mac. But if you were on a Windows machine, you could hit a Control key. That brings me right back to my main page, and I'm going to create something called a new document. And I'll just call it the chassis, right? Excuse me. So you see right away, I have a brand new blank document. It doesn't ask me if it's a sheet metal part or a weld or assembly or anything. It's giving you a part studio and an assembly and a document that you can start with. I start with the Part Studio, I sketch a shape out, right? And I give it the size. How big is this? I'm going to say it's 3 feet in that direction and 2 feet in that direction. It's units aware, of course. You can type in those units. I'm working 2 millimeters, so maybe, I'll just switch that to inches just for this. And if I went back into that sketch, you'd see it's 36 by 24, right? So we have this basic shape here in place. It's a parametric sketch. We could locate the center of that right on the origin, and I have a shape. And I'll, how should I make this, right? That's the next thing that I want to do. Like there's several ways of working in sheet metal and Onshape. And the first thing I'm going to ask myself here is, should I make it with the extrude feature, convert, or thicken feature? So I'm taking almost a fourth approach here. Like, let me just start basic, right? Here are the sheet metal tools in Onshape, just falling off the edge right here. And the first button is where you start. You tell it that you want to create a sheet metal model. And this is the question: extrude, convert, or thicken, right? What convert does is it takes an existing solid body and it will help you find all the faces. Great for complex shapes. Extrude is kind of like the traditional method if you've used any other kind of CAD that has sheet metal in it. You can see that I just picked 3 edges and I just pulled that out. Right there at 12.4 inches. It's asking for a bend radius and a thickness for the material gauge and, the bend radius for your tooling equipment. The thicken option is like taking any face and thickening it. So you can see I'm just taking that flat and thickening it to the thickness. Pardon me. The way I'm going to go about this is because if you remember back on this generator right here, we have all these different parts, kind of coming into it. I could actually kind of paint on some sketches on here. So let's just go back to that chassis, and I'll just do normal extrusion like you would find in any other, CAD. I'll just do a 24-inch box for the height. And this part right here was generated, and I'm going to call that the reference, just to kind of, know that I'm not really going to use this as a full part, but I have this shape as a reference. And remember, I have those doors and other things I want to like kind of peel off. So I'm going to draw a line here, right? And I need to dimension it, so I'll hit the letter D on my keyboard and say it's a 2-inch offset that I'm going to have for a that goes around this part. And then maybe I know I have a rectangular shape, something like this. I could always, center these things and all that too. So, there's that center point right here. If I wanted to utilize that, I might just drop in a center line. Onshape has a, keyboard shortcut. So I'm just going to hit the letter Q to turn that into a center line. And then I'm going to make these symmetrical. And there's the letter S on your keyboard. This is a pop-up toolbar, so I have a bunch of my shortcuts on that S key, so I can just quickly get to that. So I'll go to that shortcut toolbar quite a bit. So if you see that pop up, I'm just hitting the letter S on my keyboard. All right, so you see I'm starting to kind of build out a sketch of the front, and I'm just going to rename it front. So I have the extrude, I have the front. Now what, right? Now, I know that I have a cutout here, cutout here. You see it's like highlighting these regions for me automatically. So now I have places where I can start making sheet metal parts. I'll do a sheet metal model on the top, and I will thicken that top shape. You can tell if you want to go up or down, right? And I'll take 1/8 of an inch. Now, this is I'm going to call this out. It's kind of a controversial thing. Let me just hide my my video here so you can see what I'm showing you a little bit better. And we zoom in over here, to this area here, you can see it's flipping up and down. And this thickness right here, that's the gauge that you're going to buy from the sheet metal, materials supplier. Dirty secret about materials around the world in supplies that like your 9-gauge aluminum sheet metal might not be the exact same thickness as it would be from one vendor to another and from one region to another. So these are things that you have to kind of pay attention to in sheet metal design. I've hit this quite a few times over the years. So you can obviously type in a number, or you can create a list of numbers that you can reference in the future. We have variables in Onshape where you can have various values that you could draw from. Toward the end of the live event, I'm going to show you that because it's just a slight customization tweak, and I don't want to like derail the demo here. So, but just know that. I just know some people are thinking that right now if you're a sheet metal person. All right, so I have that first piece, and there's part 2 right there. And yeah, let me just hide the reference for a second. I'll hide this sketch just to kind of show this in isolation. Because the next thing I want to show is just, show a flange flapping over all the edges of the top of this, right? So I'm just grabbing the edges. And you can see what it's doing. It's pulling them to the outside. You have all the options for where the bend should come from, how it's aligned, right? So there's choices there for you. Do you want it to be a blind extrusion to a certain depth, like 1 inch, or do you want it to go up to some reference, right? I'm going to say up to entity and pick that point of the sketch, right? So just like that, I have a flange going all the way around. Now, if we look at this, we're going to see some new buttons appear on the side, right? If I cancel, well, it's already been there because I had one sheet metal feature already. You can see it's just a flat plate right there. But if I, let's put that flange on again. 1, 2, 3, 4. You notice it doesn't really matter which edge I pick. Onshape will know to grab the right piece, and it's showing me the flange as well as the bend relief at the same time. If there was a bend relief, it's showing you how it's tearing, right? Now, where is that information coming from? It's coming from the brain of the sheet metal model. I call it a brain, but this first sheet metal feature, you have one for every part. This sheet metal feature called sheet metal model 1 in the feature tree is how it's going to kind of default to its conditions, right? Bend radius, thickness. That's why it didn't ask me for it in the flange, right? I didn't have to, ask for the bend radius or thickness there. It's defaulting to that, of course. Material, it's being calculated using the K factor, right? So maybe, how do you, talk about, how do you declare this in your sheet metal parts, right? K factor is a common calculation for figuring out what the material will be after the material stretches and bends through the sheet metal process. All right. But bend allowance and bend deduction, you can also calculate in a similar way. So there's 3 different types of calculation methods, and I told you there's a 4th that I'm going to show later as well, which is a customization that you can add to the system. And here are the reliefs, right? So if I hit the final button, it's going to show me, it's going to roll through the whole feature tree. It's showing me the relief being a tear, but this is where you would change your release if you wanted like a round, some sort of corner, in here. If you're using punches to make your corners, you can actually see that in the flat pattern. So you're getting a high fidelity flat pattern when you're using Onshape. Let me just go back to simple corner, I think. Or, yeah, we'll do a closed corner. There we are. All right, so you have those options. And notice this sheet metal table and flat view that I'm working on right now. This table view and this flat view are all live. Right there, we're not flapping back and forth between a flat and folded state. And that's really important to understand, because this means you don't need to put like fold and unfold operations manually in your tree if you want to do something with the flat pattern versus the folded shape. It also allows you to see everything and even edit things in a tabular fashion when you learn from your supplier, what bend radius they can support, what K factor they can work with, right? So this is all editable. Like if I wanted to go to bend A and change that to a different bend radius, you can see that I've just done that. You can see the bend radius here is highlighting it. It even added a modified joint feature in the tree as soon as I change that radius, right? Now, if I want to get rid of that, I can just delete that, right? So it's almost like a funhouse mirror. That's how it was described to me the first time, I saw this. It's like you're just looking at the data in different states, but it's all live, okay? So this is really helpful once you start communicating with your manufacturer. In fact, maybe we should do that now, right? So how would you communicate this information to a sheet metal supplier in a file-based world, right? You would save the file, right? You would name it. Now, I'm going to name it cover generator chassis or whatever. So that's the name of that body that I'm working with. And it's not just a body, it's a real part to the Onshape database because I can use this in drawings, I can use this in assemblies already without doing anything special. Create drawing, right? So I probably want to create a quick detailed drawing and this cover. I'm going to go back to the model and add a comment to this. I'll just turn off the flat pattern so we have more room here. And, I want to share this information with my sheet metal vendor so that they can comment on this with me. And I'm going to bring up the comment panel, right? Just like any modern system, if you're in any kind of SaaS, pardon me, system, you can definitely label the person's name that you want to share with. This person could be a view-only user. They don't need to be a full CAD person. So, licensing is simple here. And I'm going to say, hey, sheet metal vendor, can you comment on how I have set this up? Right? And I can assign that to the vendor. I can even add a little markup, right? I can even tag entities. Like if I wanted to ask them about that particular bend, is this bend radius okay? And I assign that task to the sheet metal vendor. Now that sheet metal vendor does not need to be a full view, CAD user using Onshape. They could just be a view only person. They could be a CAD user as well, and they should be, of course, right? If they're doing their own work. But I will share with that vendor. And how does this look, right? So let's just make my window a little smaller here. And I will sign in as the sheet metal vendor in the blue window here. So on the greenish window here, I have Mike the manager at the OEM company. And I have the sheet metal vendor. And look what's already in their list of documents. They've been shared into the chassis and they can see it and they can jump in. They were getting emails noting this. If they were on their mobile device on their phone, they just probably got a notification. Notice what's down here, comment button. And there we are. Comment right there. I can reply. Now, how do I, let me zoom in here as the sheet metal vendor and I'll just go full screen here so you can see a little easier. They can see that flange or that radius on that flange being highlighted. Even though they've been shared in, I could double click. Let's see. Oh, it's view only. Let's do this. There's the comment. Let's do a measurement. I'll just pick that face and hit the tape measure. Well, there it is. The radius 185 inches. So they can reply. I can do 0.175 on the radius. Is that okay? Right? And of course, back over here, there's a comment. You see a little bubble right here that popped open. There it is. I can see the reply. And maybe that's okay, right? Maybe I can go back over here, change it to, let's see, 175 on that. Oh, 185. What am I picking? Maybe I'm losing my mind here. Oh, I was picking the outside radius. There we are. There's the actual radius, 60 right there. So you can see why, attention to detail. So we'll just say, I'll just go 90. Just make it bigger. Just so you can see something change. And that change happened for both people at the same time. So sorry for the windows here, but you can see if I were to measure over here, that's now 90 automatically on the sheet metal vendor side, right? That is pretty cool because we did not need the share files back and forth. In fact, we can even see that Mike and the sheet metal vendor in the same document at once. I can double click on Mike as the sheet metal vendor, and anything that Mike does on the screen can then, be shown as a live design review. So this is what, you're bringing in your supplier sooner. You're getting answers to questions early while you have the most influence on your design, right? Well, let's go forward. Let's continue the design process with the sheet metal vendor still having access to this, right? So, they can see everything that's happening as I'm working because I've shared them in. Now, if I wanted to kick them out, I could, right? Let's say, I wanted to do that, I could. I can just kick them out like that. And then over here, if I refresh this window, you see, they can't even see the document anymore. It's gone. Completely gone, right? That's what Onshape is like. You have full unfettered control and access to the design. Your horse is never out of the barn when using Onshape because when you send a file with file-based CAD system, that file's gone, right? You can't get that back. It's a copy of that file's on another person's computer. Things can happen. Onshape, you have, restricted control, encrypted communication, and you have full control over who can do what and when. Now, of course, I can add the sheet metal vendor back in. Maybe I even want to give them edit rights because they have an Onshape account too, full professional or enterprise in this case. So, I can tell them what they can do. They can't export, or maybe I'll let them export, but not share. They might want the flat pattern DXF, right? All right. So we have that shape. Now I'll keep on going. We have that reference shape that was here to help us. We have that front panel right here. And, I can keep on going. Maybe I'm going to have I'm going to thicken this piece right here. Right? So I can pick that face, thicken that, pick the direction I want to go in, and continue forward. And that's another set of rules for that. It's another part. Power tip for existing Onshape users. Every time you create a new piece of sheet metal, it shows up in this list for the flat patterns right here. If you rename these to something more meaningful, then it makes a lot more sense, right? If I take the feature and rename that to, what it is, it shows up over here. Okay, so it's very easy to see. All right, we'll keep on going. Keep on going. All right, so, flanges can work across multiple parts, by the way. So if I, pick this edge and this edge for a flange, I could have also picked a part, from another piece as well. It's even highlighting it in the flat pattern right there right now. So just know that that's not a limitation in Onshape whatsoever. You can add features to more than one part at once. Sometimes that's really helpful to establish the nice parametric definition of it. So, when you're adding your flanges, hems, tabs, they're inherently multi-part, especially tabs, right? So we have flanges, hems, and tabs. Hem is essentially, let me just get rid of that other piece. If you take a look at a hem, you'll probably know what I mean once I show it to you here, or you probably already know what I mean. There's a hem. And we can fold that over, right? And that's a little too big. We'll just say 1/2 inch. There we are, just fold it right over. But there's different types, rolled hems for like a piano hinge or a teardrop style as well. So all that's here in the system. You can also draw in the folded view as well. And I'm going to get into sketched bends here in just a second. But in this case, I want to draw a rectangle from the center of this corner out here at 5 by 5. And guess what? I can make a cut right there. It's going to remove the material just like that. So sometimes it's easier to do it in flat pattern versus the folded shape, especially when you have curved kind of geometries. If you have, a complex kind of set of conditions, all these parts kind of interacting, working together, or a consumer product where you have a bunch of sheet metal kind of working together and you want it to like cut, in a certain way, in its folded state, that is where you'd want to cut across a bend. Let's go back to the chassis kind of workspace that I'm in. All right. I'm going to take a little time out here before I get into sketch bends because I have, if you're probably nervous as heck because you haven't seen me hit the save button yet. But if you've seen Onshape or used Onshape, there isn't one. There is no need for one. Onshape records every single operation in your design. Here is a full list of who did what and when in the design. Now I said who did what and when. It's just been Mike doing the work right now. But you can see the whole list of features of who made the changes. In fact, if I did share the sheet metal vendor with edit, if I share with me again, there's the chassis for the sheet metal vendor to look at, and the sheet metal vendor can actually go in. And because I gave that sheet metal person edit rights, they could make that change, right? And of course, I would see that change right there immediately. The sheet metal vendor made that change. I know it happened. But I could, restore back before that change happened, right? We have full history of the entire design. And we can label versions in time. And in fact, branch as well. Try out different ideas. Maybe I want to do a DFM study on this, right? You branch off, you find your branch, you do your work, and you're working on a branch. And sheet metal vendor can work on that branch, right? Something new we just added is this thing called workspace protections, which comes in really nice in these kind of situations where maybe you don't want the sheet metal vendor to ever change your main workspace, right? So I go to the properties, I go to the workspace protections here, and I'll just tell it to update that drawing and enable the protection. So now on main, things can only be brought in from main from other work, right? So I'd be working on this DFM branch, doing my ideation and work like that. Then you would merge the changes in. So let's kind of experiment with that. We're both on this DFM branch. And let's add some more things. And we'll just pull out another piece of material here. There we are. In this one, I'm going to sketch a bend on here, just to answer that question. So you can draw a bend in place. So I'm just going to peel that corner back. And there's the bend operation right there. My bend line is here. And of course, it's showing you, the fold in place, and then you would just tell it what your angle is. So a common workflow, if you're dealing with any sorts of folds like that, if you're doing with any kind of fold like that, that's how you would do it, just a straight line, right? So There's a few questions that I'm noticing coming up. I've been, flying around, through the system here, and hem. One question from Jessica is that a hem on a circular profile. I don't think that's gonna be a thing here as well because of the way it would need an advanced forming tool to create a hem on a circular edge. So we only support hems on straight edges currently. But thank you for the question. All right, let's keep on going. Next up. So that's a sketch bend. Just know that you can do that. How do you get to manufacturing is going to be the next kind of thing. And can you use the whole feature on a flat pattern? Oh, that's a good question. I think you would probably do it. Yeah, because right now in the flat pattern, it's sketched shapes, right? You can sketch and then extrude, right? And that's the way we can sketch on the flat pattern, but we can't put like a feature, like an applied feature on there, William there. So I would say use the, if you wanted to put in holes or locations, if I go back to my previous design right here that I built that a little bit more fully here, you can see the holes here on the part, and I put the holes in, at that moment as it's been folded up. So let me just roll here. Right here are my drilled holes. Right. So what I typically do is I create, the sketches right there on the folded shape. And the reason I did it here was because I'm the OEM designer and I'm designing through multiple parts. But if you're just doing one sheet metal part at a time, you might not need to go to this level of thinking. But you can see I've got just a bunch of points on this. And then I have an M10 hole, countersunk hole. And that's kind of newish for Onshape, the ability to support counterbore and countersunk holes drilling through sheet metal. So that's supported. And you can see it's drilling, it's using all the points that I wanted it to pick. And by the way, like I don't have to pick every single point. I can just pick the sketches right here. So I have 4 sketches for the 4 faces that I put holes on. And it's going to drill, through all of them without me having to pick every single point, right? And I told it to drill through all the possible parts, right? So that's how I did that. But, flat pattern is just sketch-based operations, if you want to sketch on the flat pattern. All right. What do I have next in my bag of tricks here? Company-specific features. So this is something that, comes up with especially a sheet metal manufacturer, right? That knows exactly what they have for materials and the equipment they have on the shop floor for the press, brake press and everything. So the way you would do that in Onshape is to, create... there's a few ways of going about it, but I'm going to show you the method that I've kind of gravitated toward lately, is to set variables that are driven by Onshape's custom programming language called FeatureScript. So you can see here, I have a radius value and a thickness value, right? Because when you do, people call this bend tables and some other CAD software, where they'll pull in an Excel spreadsheet with their custom data. And if you pick a certain type of material with a certain gauge thickness, it's going to present to you the available bend radii for that, right? And these are all very specific to each company that you would want to work with. So it's tough to provide that as a global kind of operation. So that's why a custom feature comes in really nice. Onshape is open sourced all of its programming language, so you can make your own features or use features that other people have built. In this case, instead of going into the sheet metal feature and typing in, 1.25 millimeters and 0.15 millimeters of bend radius here, I could call out these variables. And by the way, variables are something that you can create, on the fly or as a table, as its own, its own tab inside of a document, right? So here's a variable studio, and I could say, height is going to be, length, and it's going to be 45, and you can build this entire table and reference it throughout all of your designs, and it's extremely powerful. Global variables, just look it up. Variable studios, right? But where it doesn't, really help you is like if you have one value kind of driven from another, right? So let me delete that. It's already gone. Okay, good. So this feature right here, and you'll find these on the Onshape forums. The community of Onshape users is quite vibrant, and we have a very generous community that shares different ways of doing things. And this is how I found this idea was, you have aluminum or steel, right? What's your gauge, right? If I have 9 gauge steel, that's the bend radius I want. If I have aluminum, I have 2 options in this particular case. And where are these coming from? Well, it's coming from the original source document that has that information. So very easy, human readable here. This is what feature script looks like. You can customize and code your own Onshape features or just customize the ones that Onshape has. But this one's very simple because it's just displaying, okay, we're going to say if it's aluminum, we're going to have 12 gauge is the default, but we're going to have quarter plate, 3/16 plate, 1/8 inch plate. I'm going to share a link to this. I'm going to put it in a more public, this is in my enterprise account, so I'm going to put it in a public document later after the webinar and put a link to it in the chat. But you can see 3 gauge gives me this radius and that radius, right? Pretty simple, right? It's not crazy stuff. So to do this, that's all I did was insert that feature in this design, which creates these variables. So this is like the control center for the variable, right? And if I go to wall mount and go to thickness, I just type in hashtag thickness, hashtag radius, right? And now that is going to, create it using that particular size, and it will stick with that in there, right? So, this tab also probably needs to, I've changed something in here that affected that in a non-good way, right? So that's okay though, but I can go to the door mount here. Here's the door mount, and I could keep on doing the same thing, right? So you would just do that. You would insert that feature as the first feature of your model or wherever above the tree where you have your work happening, thickness, radius, right? And that's controlling all the size information right forward, right? And you could have different variable features that would be for different vendors even, right? You might have this vendor that I work with uses this set of numbers, and this other vendor that I work with uses this set of numbers. And of course, if you are the vendor, you would have your own and work to it, right? So know that you can build to completely custom features, within the system of Onshape. And it's very easy to add a feature like that. You would just, here's my list of, my bag of tricks here. And there's sheet metal variables. So you just hit add custom features. There's a bunch of samples in the community, but like I said, I'm going to share you a link to one, and you can paste that link in the search box and it will find it. And there's some on the forums as well. All right, let me just cough for a second. I still got some allergies. All right. Some people ask about PEM fasteners. How does that get handled? If you're putting your sheet metal designs together with PEM fasteners, that would be in an assembly, right? So, I don't know if I have a good PEM fastener hole, so I'm going to make one. So let's go over here. And right now I'm using a countersunk hole. Let me go to simple hole over here. And here's the end condition. And what's my standard? Well, I can choose the PEM standard as the hole type, right? When I'm designing holes, first of all. So you would just pick, I want an M10 self-clinching nut hole right there. And then what's the fastener type? And, is it going to be a clearance hole? Is it going to be, it's just all set. All the numbers are defaulted, and we have the database of PEM fasteners. Then in your assembly, so you would take this, right? This is the part design space. I would create an assembly which gives you your accurate bill of materials. And I'll just find the part studio for the chassis because I have a bunch of stuff in this document. There's the cabinet right there. Okay, and that's kind of a newish function as well, inserting the entire part studio as one collection, and it kind of stays grouped all together. We just fixed the first part in space. This is really useful for these kinds of construction scenarios where it's a fabrication and you don't have moving parts, right? It's just a bunch of fabricated items. Oh yeah, the PEM fasteners. So how do you insert those? Well, you could insert in the same dialog, right? I inserted from this document, but I could also insert from my own library of different things that I've put together, right? Maybe I have a purchased item library. But, standard content, think of this as like if you come from SolidWorks or something, this is like Toolbox, right? Or, this is just a standard content system, right? So I would go into the PEM area here, and then pick my, self-clinching nut here, metric, right? It was M10. There we are. That was the type. And I forgot what, let's say I forgot it was M10. I could auto size it based on a selection. And there it is. It just finds out that it's M10 just like that. And how many do I want? Well, I'll just pick this face. Actually, you know what? I'm going to do one. I'm going to put it right here and insert it. Make sure it goes in the way I want. Not that you'd ever put PEM nuts on this. This is going to be a normal bolt and screw. I know I'm not... I know they kicked me out of the engineering world a while ago for these kind of reasons. I'm just kidding. But, there's a PEM fastener right there. And how would I get the rest of them in there? Right? You would use the replicate function right here. Replicate that. Find any other hole in that face where it makes sense, and it just puts them in. And I can just kind of go all the way around just like that. So this replicate function works really well, especially on imported parts. Like if you import something from a vendor online, commercial off the shelf, and you wanted to fill up a valve that you bought with all the bolts. This replicate function works better than a parametric replicate, that's reading a feature, because in a commercial off the shelf item, there's not going to be a feature. You're downloading that as a step or whatever. All right, so that's that. And it's building up the bill of materials. By the way, the bill of materials is right here in the Onshape assembly area. It's a fully live interactive BOM, just like that, right? And of course, there's my PEM nuts right there. I have 28 of that part number. Okay. All right. Time is flying, so I need to keep on going here. I did get through most of the things I really wanted to talk about, I believe. So let me just go back over here and make sure I, there's definitely some other things that we can do, right? But, one thing that, is sort of newish in Onshape is publication. So if you don't want to share the entire document out, because there's other things that are private that you don't want to get out, but you want to create a publication of just the drawing of that cover. Let's say I want to make a drawing of this cover in a flat pattern. I want to make sure you know how to do that. I'll create a 4-view drawing on that B-size piece of paper. And this will be my legal document with the dimensions and inspection and all that. Of course, I could put a whole table on here with all the holes, but I'm just going to drop in a couple of dimensions here and drop in the flat pattern as well. And you would hit the insert button and filter it on flat patterns. And then here is my cabinet and the flat pattern for the top. There it is. You notice it's filling in all the metadata, of course, behind the scenes as well. Come on. And, this isn't really the way you would do a flat pattern because you really want to do one-to-one flat pattern. On a drawing, you don't really, you're not going to get that, especially for a part this big. So let's show you the other method. If you go over here, go to the top piece right here and I want to get the export for the DXF, I can export that as a DXF too. And look what it's nice enough to do. It's creating a file name for the DXF based on some rules. So I told it to look at the part number, because part number is a property that you can apply to anything in Onshape, or as you might expect. And then I just told it to create the file name based on that. So we have all these rules. Look up export rules in the help, and you'll find it. And I can export that as a DXF file and store it right in the document. Look at this. It just adds a tab to the document, and there's the DXF file for me to view. And, you can view, you can export this PDF. You could even upgrade this DXF viewer to a full 2D editing program, like a light version of AutoCAD, if you will, to make changes. A lot of vendors may have certain line types or color names that they need for their laser jet or water jet. And you can see all the layers coming through here are all configurable, so you can change that to suit your equipment's needs. Inspection as well is something that I just wanted to make sure people realize is a thing within Onshape. And let me just find a better piece of sheet metal that has a drawing on it. And I know I have it right in here. And this is our old standby here, but I still like going to this drawing here because it has it's a good story. All right. Oh, let me turn off that ticker. I think you've gotten the point that you should share with your suppliers. But I'm going to talk about inspection items right now. So, let me go to the cover here. That's a better looking one. So everybody in Onshape gets the ability to label an inspection item on their drawings. And what do I mean by that? So if I go over here to the inspection table in Onshape, I can assign inspection bubbles to all of these, right? I can assign them right like that. I can pick them on the fly like that. Or I can say automatic and just have it figure it out for me. So it's putting in inspection bubbles next to each dimension. And it will calculate if I had tolerance information on here, which I don't right now, but let's put some on. So if I said I had limit dimension of plus or minus 50 or something like that. See what it's going to do over here? It's calculating my upper and lower limits, just like that. So incoming inspection, if you're getting parts in from your supplier, you can very easily create a report, export this as a CSV file, slice and dice that in Excel, Google Sheets, whatever, and have your incoming inspection process be taken care of as well. So definitely that's just part of the Onshape system. I encourage you to check that out. So what you've seen here is a lot of stuff, but it's certainly not everything about Onshape. It's just, the way I would think about doing sheet metal in Onshape. Hopefully you were able to step in to my thought process and understand a little bit more. But I really hope you got a lot out of this. I didn't expect it to go right to the full top of the hour, but there's just a lot to talk about. We're going to keep doing sessions like this every month. So, we'll be able to, we'll be taking requests, but I think we're going to be talking about the collaborative communicative design next in the next session that I run next month. And then we'll be talking about some other, we got a whole series planned. So I really hope this was helpful. Thanks. Oh, and then let me just take a quick peek at the questions here. Multiple DXF files from Part Studio at once. I'm going to look that up for you, Imran. I have your information here, so I'll follow up with you. Thank you. All right. Thank you again. I really hope. Oh, and one other question. Is there a way to set universal value for Ben deduction directly? Gunnar, I'll get back to you on that one too. So sorry, I was up against the clock there. So much appreciated. Thank you again. Have a great day and see you again.